Today we're taking a close look at a truly significant and tragic event.
Yeah.
The Air India B787-8 accident in Ahmedabad, June 12, 2025.
Yeah, a flight that crashed almost immediately after takeoff. It's definitely a sobering event.
Absolutely. And our exploration today is built around the preliminary report, right, from India's AAIB.
That's correct, the Aircraft Accident Investigation Bureau. And it's really vital to remember their objective, their sole objective, is accident prevention.
Not about assigning blame.
Exactly, that's not the purpose of these reports at all.
That context is so important, especially with something this sensitive. So what can you expect from us today?
Well, we're going to unpack the initial facts, look at the evidence that's emerged so far, and piece together, a timeline.
A timeline of what happened to Air India Flight AI171, bound for London Gatwick, how it ended just moments after leaving the ground.
And we'll touch on the initial findings and the sheer complexity of an international investigation like this one.
Okay, let's start with the basics. The aircraft itself.
Right, it was a Boeing 787-8. Registration VT-ANB, manufactured back in 2013.
And it had seen some service.
Oh yeah, 41,868 flight hours. But its airworthiness review certificate, its ARC, was valid until May 23rd, 2026.
So on paper, completely current.
Correct. From a certification standpoint,
And the crew.
very experienced. You had an ATPL holder as pilot in command, over 15,600 total hours.
Wow.
And a lot on type 2, almost 8,600 hours on the 787.
Okay.
The co-pilot held a CPL, commercial pilot license, also experienced 3,400 total hours, over 1,100 on type.
And for this flight?
The co-pilot was pilot flying, the PIC was pilot monitoring.
And they were good to go. Rested. Checks passed.
Yes, report says well rested and both passed their pre-flight breath analyzer tests. Anything noteworthy there?
Well, the aircraft had flown in from Delhi earlier that day, and the previous crew had logged a defect.
Okay, what was it?
A PDR, pilot defect report, for a STAB POS XDCR status message. STAB POS XDCR, stabilizer position transducer?
Exactly. It's a sensor telling the flight controls the position of the horizontal stabilizer. Crucial for trim, for pitch control.
So a potential issue with knowing the aircraft's trim accurately.
Could be, yeah. So troubleshooting was essential. An Air India engineer carried it out.
And the outcome.
The aircraft was released for service, cleared for this flight, AI171.
Were there other known items, Mel's?
Yes, there were several minimum equipment list items active, which isn't unusual.
Right. MELAs allow operation with certain non-critical defects for a limited time.
Precisely. There were 4 Category C's items, things like flight deck door visual surveillance, the airport map function, stuff like that.
Okay. Non-essential for immediate flight safety.
Correct. And 1 Category A for nitrogen generation performance, plus some Category D melanels. But importantly, all were within their validity periods.
And all mandatory directives, ADs and SBs, were complied with?
Yes, the report confirms that.
Okay, that's helpful context. But then the report mentioned something intriguing, an FAA bulletin.
Ah, yes. The Special Airworthiness Information Bulletin, SAIB N1833, from 2018.
And it was about fuel control switches on the 737.
Primarily, yes, about the potential for the switch locking feature to disengage. But it noted the design is similar on the B7878.
Similar design, but the bulletin was only advisory.
Correct, not mandatory. And because of that, Air India hadn't performed the suggested inspections on their 787 fleet related to this specific SAIB.
So for someone like me, maybe not deep in the regs, what's the deal with advisory? Does that create a potential gap?
That's a really important question. Advisory bulletins give operators discretion. They weigh the information against their own operational context, their fleet data.
So it's a judgment call.
Essentially, yes. This incident, though, could prompt a relook at when advisory items perhaps should become mandatory, especially with design similarities across types.
It highlights that tension between guidance and regulation.
Exactly. Balancing cost, operational impact versus immediate mandatory action. It's complex.
Did the report say anything else about the switches on this aircraft?
It did note the throttle control module, which houses those switches, had actually been replaced twice on this specific plane. Once in 2019, again in 2023.
But for unrelated reasons.
Unrelated reasons, yes. And crucially, no fuel control switch defects had been reported on VT-ANB since that 2023 replacement.
Okay, so no prior red flags on that specific component recently.
According to the maintenance records cited, no.
Right. So checks done, status is noted. What about the final load? passengers, fuel.
All set there. 230 passengers, including 2 infants, 10 cabin crew, so 242 people total on board.
And weight.
Fuel load was 54,200 kilos. Takeoff weight calculated at 213,401 kilos, both well within limits.
Any dangerous goods?
No dangerous goods on board. Everything looks standard for departure.
Okay, so the plane's cleared, loaded, ready. Attention shifts to the runway. Let's walk through that takeoff sequence from the ATC comms.
Sure. It starts at 07.43.000 UTC. That's when they requested pushback and engine start.
Standard start.
Yep. Then at 07.49.12, they confirmed they needed the full length of runway 23.
Full length, okay.
Taxi clearance came at 07.55.15. And then the crucial call, 08.07.33 UTC, cleared for takeoff, runway 23.
And they rolled quickly after that.
Just 4 seconds later,
Yeah.
08.07.37 UTC, takeoff roll commenced.
And as those engines spooled up, the flight recorders, the EAFRs, were capturing everything.
Every critical second. That data is incredibly precise.
So what did it show?
Okay, Air 8.08.33 UTC. V1 achieved. That's the takeoff decision speed. 153 knots indicated airspeed.
Right.
2 seconds later, Air 8.08.35. VR, rotation speed. 155 knots, they start pulling back.
Liftoff.
Air 8.08.39 UTC. Aircraft lifts off. The air-ground sensor switched to air mode. Normal so far.
But then something happens almost immediately after liftoff.
Almost instantly. At Aero 8.08.42 UTC, just 3 seconds after liftoff, as the airspeed hit its peak of 180 knots.
Yes.
1 second apart, according to the data, engine 1, then engine 2, but basically simultaneously in the context of takeoff.
Wow. At maybe, 50 feet, 100 feet in the air, that phase?
Exactly that critical low-altitude, high-energy phase. And this is where the cockpit voice recorder adds a chilling layer.
What did it capture?
You hear one pilot ask the other, why did he cut off?
Implying someone moved the switches.
That's the immediate assumption, right? But the other pilot responded immediately, I did not do so.
I did not do so. So instant confusion in the cockpit. Neither pilot claims to have moved them.
Precisely. It points strongly towards an uncommanded event, something happening to the switches, not by the pilot's direct action at that moment.
And visually, from the ground.
Airport CCTV confirmed it. It showed the ram air turbine, the RAT, deploying during that initial climb.
The RAT deploys automatically when you lose engine power, right? Emergency power.
Correct. Provides essential hydraulic and electrical power. And importantly, the CCTV showed no significant bird activity.
Rules out a double bird strike as the immediate cause.
Seems unlikely based on that visual evidence.
So, engines cutting out, RE deploying.
Mhm.
What did the crew do? What did the systems do?
Well, the data shows an immediate attempt at recovery. By 08.47 UTC, just 5 seconds after the cutoff, both engines and 2 speeds, their core rotation, had dropped below minimum idle. That's when the R8 pump kicked in, supplying hydraulic power.
Okay.
Then, at 08.08.52, Engine 1's fuel cutoff switch was moved back from seat off to run.
Someone trying to relight it.
Likely. And the systems were trying too. 2 seconds later, 08.08.54, the APU inlet door started opening.
Auxiliary power unit trying to auto start.
Consistent with that logic, yes. Try and get another power source online. Then, 08.08.56, Engine 2's fuel switch also moved back to running.
So, attempts to relight both engines within about 14 seconds of the initial cutoff.
Yes, and when those switches go back to run in flight, the FADEC, the engine computer,
The brain of the engine.
right, it automatically initiates a relight sequence. It manages fuel flow, ignition, trying to get thrust back.
Did it work? Did the data show relight?
We saw signs. Exhaust gas temperatures, EG2, started rising for both engines. That indicates combustion, a relight attempt. A positive sign, yes. Engine 1's core speed deceleration actually stopped, and it even began to recover slightly.
Okay. But engine 2?
Engine 2 also relit, but it seemed to struggle. Its core speed kept decelerating, even as the FADC kept trying to inject fuel to recover thrust. It was fighting to stay lit and accelerate.
A partial recovery on one, a struggle on the other, but they were running out of time and altitude.
Terribly fast. And the EAFR data stream, the recording itself, stopped just after this at 08.09.1 UTC.
Before the data stopped, though, any communication?
Yes. Tragically, at 08.09.05 UTC, just 6 seconds before the recorder stopped, one of the pilots transmitted, "Mayday, Mayday, Mayday."
ATC heard it.
ATC acknowledged and inquired, but there was no further response. They just saw the aircraft impact the ground outside the airport boundary.
Initiating the emergency response immediately, I assume.
Instantly, the crash alarm sounded.
The impact itself, devastating.
Horrific. The aircraft struck the BJ Medical College hostel complex. It's only 0.9 nautical miles from the end of runway 23. Very close.
And the ELT, the emergency locator transmitter.
Did not activate, for reasons yet to be determined. The wreckage was spread over a large area, about 1,000 feet long by 400 feet wide.
What did it hit first?
Initial contact was with trees, then an incineration chimney within an Army Medical Corps compound.
And then the main impact.
The northeast wall of Building A in the hostel complex. That was about 293 feet from the first tree strike.
Do they know the aircraft's attitude impact?
Based on witness marks, it seems likely it hit nose up, maybe around 8 degrees, and wings level.
Which makes sense if they were trying to climb or arrest the descent.
Plausible. The fragmentation was immense. The entire vertical stabilizer, the tail fin, broke off, landed 200 feet south of Building A.
Wow.
The rear fuselage section and the right main landing gear were found embedded in Building A.
Just disintegrated.
Yes. As the wreckage continued, the right engine hit a concrete water tank on Building A's roof and separated. The left engine hit the corner of another building, Building D, at ground level.
What about the controls in the cockpit wreckage? Anything significant found?
Some key findings, yes. The flap handle was found in the 5-degree position.
Which is consistent with takeoff flaps.
Yes, and confirmed by the EAFR data before it cut out. Normal takeoff setting. The landing gear lever was found in the down position.
Gear still down, okay. Throttles.
Both thrust levers were found near the aft position, so near idle. However,
There's a catch.
a critical one. The EAFR data, right up until it stopped recording seconds before impact, showed the thrust levers remained forward in the takeoff thrust position.
So the levers were physically found near idle, but the data shows they were commanding takeoff thrust right until the end.
That's the discrepancy the investigators will be looking at very closely. Impact forces could have moved them, or something else.
And the fuel control switches, they were found.
Found in the ORN position, which is the normal position for flight.
Despite the EAFR showing them momentarily going to cutoff right after liftoff.
Correct. Again, consistent with the recovery attempt, or perhaps moved during the impact sequence. Lots to analyze there.
The human cost, it's just staggering.
It's truly heartbreaking. All 12 crew members, the 2 pilots, 10 cabin crew, and all 229 passengers on board, none survived the impact.
And on the ground.
19 people tragically lost their lives in the hostel complex. Another 67 suffered serious injuries. 260 fatalities. 68 serious injuries, plus 5 buildings with major structural and fire damage. An immense tragedy.
That scale of loss.
Yeah.
It just puts incredible focus and, frankly, pressure on the investigation, doesn't it?
Absolutely. Every single piece of evidence, every data point carries the weight of those lives lost. The responsibility to find answers to prevent recurrence is enormous.
And the emergency response?
It was swift. The airport's crash fire tender left the airport grounds at 8.14.4 UTC, heading to the site. Local emergency services joined them very quickly.
Now let's talk about that investigation. It's a major international effort.
It has to be. The AAIB of India is leading, naturally, supported by their DGCA, but aviation is global.
So NTSB is involved from the U.S.?
Yes, as the state of design and manufacturer for Boeing. They sent accredited representatives and technical advisors.
And others too. UK, Canada?
UK, Portugal, Canada all had citizens on board, so their accident investigation bodies appointed representatives as well. They were all on site.
Plus a whole range of specialists.
You need them. Pilots, engineers, medical specialists, psychologists, and critically, flight recorder specialists.
Let's talk about those recorders, the black boxes. You mentioned EAFRs.
Enhanced airborne flight recorders. 2 on this aircraft. 1 standard location in the tail, another one up forward.
And the forward one had special power.
Right, a RIPS, Recorder Independent Power Supply. Keeps it recording for a time even if ship's power is lost.
And both have the CPM, the crash protected memory. That's the heavily armored part.
Designed to survive. But survival doesn't always mean easy data retrieval, right? Not always. The aft EAFR found on the roof of Building A was badly damaged by impact and the post-crash fire.
So, no data from that one.
They couldn't download it, unfortunately. But the forward EAFR,
found near Building F, also damaged.
burnt, covered in soot, yes. But crucially, its memory unit, the CPM, appeared intact. Good condition internally.
But getting the data out wasn't straightforward. Needed a golden chassis.
Exactly. These things are so specialized. To safely access the memory module from the damaged forward recorder, they needed an identical functioning EAFR unit, the golden chassis, plus specific download cables.
Where did they get those?
They had to be sourced from the NTSB in the USA. Highlights the technical challenge and the need for international cooperation. You can't just plug these into a laptop.
When did they arrive?
June 23rd, and the very next day, June 24th, the team successfully downloaded the data.
And they got good data.
Excellent data. About 49 hours of flight data, including the entire accident flight, plus 2 hours of cockpit voice recording. Initial analysis is complete.
That's incredible work under difficult circumstances. A testament to the recorders and the teams.
Absolutely. That forward EAFR data is central to understanding those critical seconds.
And other investigative work is ongoing.
Yes, lots. Wreckage recovery and layout in a secure hangar for detailed examination. Both engines retrieved, quarantined for teardown analysis.
Fuel samples checked out okay.
Yes. Samples from the refueling Bowsers and the airport storage tanks were tested, found satisfactory. Standard procedure.
Witness statements. Survivors from the ground.
Yes. Statements obtained. And post-mortem reports are also being analyzed as part of the comprehensive medical investigation.
So a huge amount of work done, but it's still preliminary.
Very much so. And it's important to stress, at this stage, the preliminary report makes no safety recommendations, meaning they haven't yet identified a specific, actionable cause that requires immediate changes for Boeing 787 or GE engine operators worldwide. The investigation needs more time, more analysis.
They're still reviewing all the evidence, records, information.
Exactly. This is just the first official look.
Okay, so recapping what we've learned today.
Yeah.
It really throws into sharp relief just how meticulous these investigations are.
Absolutely. The level of detail, the international cooperation.
And the critical role of those flight recorders, piecing together events that happened in fractions of a second.
Yeah, without that EAFR data, especially the forward unit, understanding the sequence, like those fuel switches, would be incredibly difficult.
And even this preliminary report reveals such startling details. The switches, the pilot's immediate "I did not do so" exchange, it's chilling.
It is, and every piece of information, even the puzzling parts right now, feeds into that core goal: prevention.
Learning from tragedy to make flying safer.
That's the ultimate purpose. Understanding these initial facts helps the entire industry learn, adapt, and improve safety for everyone.
So it leaves you thinking, when every second counts, and technology is so deeply intertwined with human action, how do these incredibly detailed investigations, even at this early stage, highlight that constant learning curve in aviation safety? It pushes us, doesn't it?
Yeah.
To look beyond just what happened and really dig deep to understand why.
That's the enduring challenge and the mission of every investigation like this one, always striving for safer skies.